Good morning, dear students, and welcome back to our online classes. We have our sixth lesson in numeracy today. In this lesson, we are going to cover how to convert fractions to decimals. The title of the lesson is Fractions, Decimals, and Mixed Numbers in your books on page 86. Our learning objective is what are the mixed numbers and how to change fractions into decimals. The vocabulary we need to learn in this lesson is mixed numbers. Just a quick reminder of the place value system we covered in the previous lesson. This is what it looks like. Here we have the hundreds, then tens, then ones. Right next to ones, we have the decimal point that separates the whole numbers from numbers that are parts. And right next to the decimal point, immediately we have tenths, and then we have hundreds. Tenth is 1 part in 10 parts, and hundreds is 1 in 100 parts. For example, if we have 10 equal parts, one of these parts is a 10. And for hundreds, if we have 100 equal parts, one of these parts is hundredth. Tenth is written like this, and 100th is written like this. The denominator here is 10 because the total amount of parts we have is 10. And here the denominator is 100 because the total amount of part here is 100. If our denominator is 10, we are writing the number right after the decimal point. And whenever we have 100, if our denominator is 100, we are writing our number right here in the hundredths place. Okay, let's see how 1/10 looks like on the number line. Here, this is our number line. We put 10 spaces between 0 to 1 because we have 10 right here. That's the total amount of spaces we need to have. 1 out of 10 is right here because it's just like if we have a whole pizza and we cut this pizza into 10 equal slices, one part or one slice becomes 1/10. Here, if we have 2 parts, we will have 2/10. 3 parts, 3/10, and so on. 1/10 looks like this, 0.1. Now we've studied this and we put this on our number line 0.1 until 0.9 in our previous lesson, if you remember them. Let's have another example, 4 out of 10 or 4/10. 4/10 will be right here, and again, if you remember, we put as a decimal point which was 0.4. Because our denominator is 10 in both cases, we put the number above right here, right after the decimal point, because that's the 10th place. What about if we have one digit over 100? Because it is a hundredth, we have to move 2 places after the decimal point to put our number in. Yeah, because it's 1 part out of 100 parts. This is the tenths and this is the hundredths, and this is 1 over 100th. So we put the number 1 in the second digit after the decimal point, which is right here. What about if we have 75 out of 100? We will write it like this, because this is the 10th part and this is the 100th part. 75 over 100. Okay, let's look at this again. So 1 out of 10 equals to 0.1 in the decimal point. 0.1 is exactly the same as 1 out of 10. It's just 1 out of 10 is in fraction and 0.1 is in decimal. 2 out of 10 is exactly like 0.2. 3 out of 10, 0.3. It just means 3 parts out of 10 whole parts. Why? Here we have the denominator, which means we have 10 parts, and here we have the number 3, which means we have 3 parts out of 10 total. 3 parts of the pizza, this is 0 because it says we don't have the entire pizza, we only have 3 parts, and we put it into the 10th place. 4 out of 10 is equal to 0.4, and so on. Okay, now let's look at some fractions and convert them into decimals. 15 out of 100 equals to 0.15. We have 2 zeros, so we need to have 2 place values after the decimal point. 9 out of 100 equals to 0.9. Again, even though it's one digit, but because we have 100 here, 100 has 2 zeros, so we need to have 2 places after the decimal point. We don't have any tenth here. This is the hundredths. It means we have 9 parts out of 100. So we put it right in the hundredths place and put a 0 in the tenth place. We have 32 out of 100, which equals to 0.34. 87 out of 100 equals to 0.87. Okay, now please pause the video and match each fraction to its equivalent decimal number. Welcome back to the video. Let's look at the answers. 5 out of 10 is equal to 0.5. 0.2 is equal to 2 out of 10. 0.9 is equal to 9 out of 10, and 6 out of 10 is equal to 0.6. But changing fractions into decimals is not always that easy. What if the denominator was not 10 or 100? In the fractions that had 10 or 100 as a denominator, we knew exactly where to put the numerator, the number above. We knew our place value because of the denominator, 10 or 100. But for example, 1 out of 2 or 3 out of 4, how can we change these numbers into a decimal number? Because we don't have 10 or 100 as the denominator. In cases like this, we are using long division to find out the decimal number. Let's see how. Converting fractions to decimals using long division. For example, 1 out of 2. What we are doing in long division is to divide the numerator to the denominator. The number on top, we are dividing it to the number in the bottom. Now, if you notice, we cannot divide 1 by 2 because 1 is a smaller amount. We already know in order to divide, the number under here should be bigger. But it's not, so we need a little bit help. If you ask yourself how many 2's we have in 1, 0. So we put a 0 here and a decimal point. Then we put a 0 in front of the 1 to become 10. That way we can divide 10 by 2. Now, we've previously said that multiplication and division, they are opposite to each other. So, in order to find out how many 2's we have in 10, we can just look at the multiples of 2. Whatever number we are multiplying by 2 to get 10 is our answer right here. Now, let's look at the multiples of 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and 2 times 5 is 10. We have the exact number. We are writing 5 like this. 5 times 2 is 10, and we are subtracting here. Now, 10 minus 10 is 0, so we don't have any remainders. We don't have any remainders, and when we don't have any remainders, our work here is complete. So 1 out of 2 equals to 0.5. Now let's look at another example. 3 out of 4. Okay, again, we don't have any 4 in 3. Hold up 3 fingers. Do you see any 4 here? No, so since we don't have any 4 in 3, 3 is smaller, we put a 0 and the decimal point. Please do not forget the 0 and the decimal point. They are extremely important. After that, we need help from 0 to make 3 30. That way our number gets bigger and we can divide 30 by 4. Now, we will write the multiples of 4. Let's if we can get 30 or a number that is very close to 30. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5, that should be 20. Yes, 20, and 4 times 6 is 24, 4 times 8 is 28, and 4 times 8 is 32. Now, if we look at it, so far we reached 30, which is a bigger amount than 30, but we don't have a number. If we multiply it by 4, we get exactly 30 by it. So in cases like this, we get the number that is closest to 30. We have two numbers that are close to 30, 28 and 32. But since we are subtracting here, we cannot use the 32 because 32 is bigger than 30 and we cannot subtract 32 from 30. So we are using the next closest number, which is 28 here. 32 is too big, so we are using 28. Now, what number if we multiply 4 by it, we get 28, 7. So 7 multiplied by 4 equals 28. 28 subtracted from 30 equals 2. Again, we cannot divide 2 by 4 because it is smaller. So we need help. We get a 0 next to the 2 to become 20. Okay, now if you go back to the multiples of what number, if we multiply it by 4, we get 20. That's right, 5. So 5 times 4 equals 20, and that way we don't have any remainder in our long division. So 3 out of 4 equals to 0.75. Now we know how to convert those fractions that don't have 10 or 100 as a denominator. We are using long division for them. We always divide the numerator by the denominator. The numerator is way smaller than the denominator, so we need help. And we put 0 right to the number to make it a bigger number. That way we can proceed with our long division. Sometimes, no matter how much we divide the number, we always end up with a remainder at the end. So at cases like this, what do we need to do? In cases like this, we divide the number until we have 3 places after the decimal point, meaning we are dividing the number 3 times. Let's look at this example. We have 1 out of 3. Now, 1 with 3. Again, because 1 is smaller, we are putting a 0 next to it, and then we are putting 0 with the decimal point at the top. So now we should look at the multiples of 3 to get the closest number to 10. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. Now, 12 is bigger, so we need to multiply it with 3 to get 9. 9 is the closest amount we can get to 10. 3 times 3 is 9, and again, we ended up with 10. We put another 3 and 9. So as you can see, no matter what we do, we always end up with 1. So what we do is dividing the number for 3 times until we get 3 places after the decimal point, then just leave it like that. So since we have 3 places after the decimal point, we will just stop right here. Please remember to always divide 3 times until you have 3 places after the decimal point and then leave it. Alright, let's look at another example, 1 out of 8. Now we are dividing 1 by 8 again. We don't have any 8 in 1, so we put a 0 with a decimal, then a 0 next to it. We are looking at the multiples of 8 to find out the closest number to 10, which is 8. All right. 1 times 8 is 8. If we subtract 8 from 10, we get 2. Again, 2 is too small, so we are putting a 0 next to it to get 20. Now we should go back to the multiples of 8 to find out the closest number to 20. 3 times 8 is 24, which is too big, so we are just sticking with 16. 2 times 8 equals 16. So 2 and then 16 there. If we subtract 16 from 20, we get 4. We stop because 4 is too small for 8, so again we put a 0. Whenever this number right here is too small for this number, just put a 0 next to it. 40 is in the multiples of 8. Can you guess what number, if we multiply it by 8, we get 40? You guessed right, 5. 5 times 8 is 40. We subtract it and we get 0. Our work is complete. So 1 out of 8 equals to 0.125. That's why it is very important to keep dividing until we have 3 places after the decimal point, because if we just stopped right here, our answer would have been wrong. Okay, now a bunch of more examples. Okay, the 0 and the decimal point. We get a 0 to 1 to become 10, and then find the closest number to 10 in the multiples of 4. The closest number to 10 is 8. Okay, 10 minus 8 is 2. We put a 0. What number, if we multiplied it by 4 with 4, we get 20? It's 5. 5 times 4 is 20. We get 0 and our work is complete. We don't have to do anything else. Okay, so 1 out of 4 equals to 0.25. Let's do another example. 2 out of 5. 2 is too small, so we put 0 in the decimal number, then a 0 next to it. Okay, we need to multiply 5 with a number that gets us to 20. Let's look at the multiples of 5. 5 times 4 equals to 20. So 4 times 5, 20. We minus it and then we get 0. So 2 out of 5 equals to 0.4. Another example. 4 with 7. Again, 4 is too small, so we borrow a 0 and then put O with the decimal point. Then we look at the multiples of the number 7 to get the closest number to 40. 7 times 6 is 42, and 42 is too big, so we just stick with 35. Okay, 5 times 7 is 37. 40 minus 35 equals to 5. Alright, now we have 50. We have to keep going until we get a number that is closest to 50. 56 is too big, so we are sticking with 49. Okay, 7 times 7 equals 49. And then if we minus 49 from 50, we get 1. 1 is too small, so we put a 0. 1 is too small, so we put a 0, and then we need to find the closest number to 10 in the multiples of 7, which is 1. 1 times 1 is 7, and if we minus 7 from 10, we get 3. As you can see, no matter how much we divide, we will still have a remainder. But since we've done 3 places after the decimal point right here, we can just stop. Okay, so 4 out of 7 equals to 0.571. Now, if we remember in the previous lessons, we were talking about how not all numbers are full numbers or whole numbers. Sometimes we have parts. What if we had an apple and a half? How would we represent that in decimals? We would represent it as 1.5. But the question is, how would we represent an apple and a half in fractions? Because we have one apple, it means we have one full number. And then we have parts, a half an apple. How would we represent that? We will write it like this in fractions. This one is for the one full apple we have here, and 1 out of 2 is for the half apple, because we know halves are represented as 1 out of 2 in fractions. This number right here is a mixture of a whole number and a fraction. This is a type of number that is called mixed number. A mixed number is a number that is a whole number and a fraction. For example, if we had half between 0 and 1, because we don't have any numbers here, this is nothing, this is 0, so we will represent the half like this. It's half, it's not full, and it is represented as 0.5 in decimals. So 0.5 equals to 1 out of 2, and they are both halves. But what if we had that half between 1 and 2? It's not the same as this picture, because we have a full pizza already. We just added up another part to it. Yeah, so right now we have one pizza and a half. It is represented as 1.5 in decimals. Let's look at this picture and see how the parts of pizza were added up to each time. Here we have a part of the pizza, which is 1/10. We added parts to the pizza until we had one full pizza, which is represented as a full number 1. And then we kept adding to the pizza with one part. Here we have a pizza and one part, which is represented 1 and a tenth. Then we added 2 parts. We have 1 and 2/10. Then we added 3 parts to the whole pizza. Now we have 1 and 3/10. And so on. We are adding up to the pizza until we get 2 full pizzas. We have the 2 full pizzas right here. If we still kept adding on it, we will have 2 full pizzas and 1/10. Then 2 full pizzas and 2/10. 2 full pizzas and 3/10 until we reach 3 whole pizzas. We can still keep going between 3 and 4 and 4 and 5. And we call the numbers between the full numbers or the whole numbers mixed numbers. Okay, now we've learned mixed numbers and how to convert fractions into decimals. Let's go back to the book and solve some examples. If you go to your books on page 86, the first exercise we have here is let's investigate. Each cloud contains the digits from a fraction and its equivalent decimal. The digits have been mixed up. Write the fractions and the equivalent decimal for each cloud. So each cloud contains a fraction and its equivalent in decimals. Equivalent means exactly the same or equal to. Now pause the video and write the answers. Find out the fractions and its equivalent in each cloud. Welcome back to the video. Let's look at the answers. Cloud number 1, we have 4 out of 8 equals to 0.5. 0.5 is in half. Why did we decide that 4 out of 8 was equal to 0.5? Because 4 is exactly half of number 8. So it's equal to 0.5. Then we have 3 out of 10 equals to 0.3 and 2 out of 5 equals to 0.4. Alright, in our next exercise we have a number line. The question says use the number line to help you find the larger number in each of these pairs. So if you look at the number line, just like that, the parts or the numbers will get bigger as we go to the right because we go from zero and parts into whole amounts, right? Now, here we have 0.3 and 0.5. 0.3 is here and 0.5 is here, so the part gets bigger. So right now, the larger amount is 0.5. What about 0.2 and 1 out of 2? 1 out of 2 is exactly the same as 0.5 as we can see here. And 0.2 is here and 0.5 is here, so the larger amount here is 0.5. We have 0.25 and 1 out of 2. Again, 1 out of 2 is 0.5. Here, even though we have 25, remember 25 is in the hundredths, and the hundredth is way smaller than the tenth. We said that the hundredths are in between the tenth. So 0.25 is between 0.2 and 0.3 right here. 0.5 is bigger than 0.25. Then we have 0.6 and 1 out of 2. Again, 1 out of 2 is 0.5. We have 1.5 here is an 0.6 here. 0.6 is bigger than 0.5. We have 1 out of 4 and 0.4. 1 out of 4, as we've done it in the exercises before, equals to 0.25. 0.4 is right here and 0.24 is right here. So 0.4 is bigger than 0.25 because the hundredth is way smaller than the tenth. We have 1 full, this is 1 full, and 0.9. Obviously 1 is bigger than 0.9. Then we have 0.5 and 0.25. Again, 0.25 was here and our 0.5 is here, so 0.5 is bigger. We have 1.8 and 1 out of 4. 1 out of 4 is 0.25. Obviously 0.8 is bigger because it falls right under there, while 0.5 is here. Okay, exercise number 2 on page 86 says, this table shows a fraction and its equivalent decimal. Copy the table, then complete it. We have this table. We should fill it out with the equivalent fraction on the opposite side. For example, we have 1 out of 10. We need to find the equivalent fraction for it in decimals. Right, 1 out of 10, we convert it into a decimal. We divide 1 by 10. 1 is smaller, so we put 0 and the decimal point, then we add a 0. Okay. We have 10 right here. What number, if we multiply it with 10, we get 10? 1. 1 times 10 is 10. So 10 minus 10 is 0. Our work is complete. 1 out of 10 equals to 0.1. Okay, so the decimal equivalent for 1 out of 10 is 0.1. Then we have 0.75. Because 0.75, we have two place values here, tenth and 100th. Obviously, the denominator is 100 because we have two places. And we immediately put the 75 over the 100. That's how we found the equivalent fraction for 0.75. Now we have 1 out of 4. Okay, 1 out of 4, we divide 1 by 4. We put the 0 and the decimal point and the 0 next to 1. We find the number closest to 10 in the multiples of 4. It is 2 times 4 is 8, and 8 minus 10 is 2. We add another 0 because 2 is too small. If we multiplied 5 with 4, we get 20, so 20 minus 20 is 0, and our work is complete. 0.6, because this is a decimal and we only have one place value right here, which is the tenth, so our denominator must be 10. And then we put the 6 in the numerator's place. And that's how we solve the questions. Alright, question 3 on the same page says, which ones are greater than 1 out of 2? We have a bunch of options. We need to pick those who are greater than 1 out of 2. Okay, we know that 1 out of 2 means 0.5. The easiest way to find out the ones that are greater than 1 out of 2 is to turn all the fractions into the decimals. Let's see. We immediately know that 0.55 is bigger than 0.5. And then we have 6 out of 8. It's better to turn it into a decimal. We need to find out the number that is closest to 60 in the multiples of 8. All right. The number that is closest to 60 is 56. If we multiply 8 by 7, we will get 56. And 56 minus 60 is 4. Now, 4 is too small, so we add another 0 to it, and it becomes 40. 40 is a multiple of 8. If we multiply 5 by 8, we get 40. 40 minus 40, we get 0. So 6 out of 8 is equal to 0.75. Now 7 here is in the 10th place. 5 here is in the 10th place. 7 is bigger than 5, so 0.75 is bigger than 0.5. And says 0.75 is equal to 6 out of 8, so we can say that 6 out of 8 is bigger than 0.5 as well. Again, 0.7 is bigger than 0.5 because 7 is bigger than 5 and they are both in the 10th place. Then we have 0.34. Now, even though it's 34, don't mind that. Just compare the numbers in the 10th place to each other. 3 is smaller than 5, so 0.35 is smaller than 5 and we will not pick that. Okay, our next number is 3 out of 4. We turn it into a decimal, 3 divided by 4. Okay, we need to find a number that is closest to 30 in the multiples of 4. Okay, the number that is closest to 30 in the multiples of 4 is 28. 7 times 4 is 28. 28 subtracted by 30 is 2, and we add a 0 to it because 2 is too small to be divided by 4. Now, we need to find a number in the multiples of 4 that if we multiplied 4 by it, we get 20. 5 times 4 is 20. 20 minus 20 is 0, and our work is complete. So 3 out of 4 equals to 0.75. Now again, 0.75 is bigger than 0.5, so we are picking that as the ones that are greater than 0.5. Okay, we only have two numbers left. We need to find a number in the multiples of 6 that if we multiply 6 by it, we get 30. 5 times 6 is 30. And 30 minus 30 is 0. Our work is complete. 3 out of 6 equals to 0.5. So it is equal to 0.5. It is not bigger. All right, the last number we have here is 0.45. 0.45 is smaller than 0.5 because 4 here is smaller than 5. It is not bigger. Our answer should be like this: 0.55, 6 out of 8, 0.7, 3 out of 4. All these are greater than 1 out of 2. 3 out of 6 is not greater than 1 out of 2, but because it equals to 0.5. And 4 is smaller than 5, so 0.45 is smaller than 0.5. We're not picking that as well. Same goes for 0.34. The question asks us to pick two fractions that are equivalent to 0. Please remember that equivalent means equal. Now let's watch the video to see how should we pick the two equivalent fractions for 0.7. Okay, 7 out of 10, we divide 7 by 10. Okay, then we have 1 out of 70. We divide 1 by 70. But this is not your usual division because here 70 is two digits. So we have one digit here. We need to have one digit here as well too. So we need to put this 0 here. That way we have 0, the decimal point, and another 0. So now we are only concentrating on division between 1 and 7. Again, we add 0 to the 1 because it's too small. How many sevens we have in 10? We have only 1. One times 7 is 7. 7 subtracted from 10 is 3. Then we add another 0, 30. Okay, we need to find a number that is closest to 30 in the decimal in the multiples of 7. 28. 4 times 7 is 28. 28 subtracted by 30, we get 2. Again, 2 times 7 is 14. 20 subtracted by 14 is 6. Now, no matter how much more we divide, we will still have remainders. So since we divided it 3 times, we can just stop right here. As we can see, the result is not equal to 0.7, so we are not picking that as well. Alright, 70 out of 100. 70 out of 100 is too big of a number, so we are just finding its equivalent fraction that is smaller. For equivalent fractions, we only use division or multiplication. Since we need a smaller number, so we need to use division. We are dividing both top and bottom by 10 because they are both equivalent, because they are both multiples of 10. Now, the 0 of the 10 goes away with the 0 of the 70. And the 10 of the 10 goes away with 10 of the 100. And now we are left of 7 out of 10. And then we have 1 out of 7. Again, we are converting it into the decimal by long division. Again, no matter how much we divide, we will still end up with a remainder. Now we have 3 places after the decimal point. We can just stop. One out of 7 equals to 0.142, and it is not equal to 0.7. So the only two answers that are equivalent fractions of 0.7 are 7 out of 10 and 70 out of 100. These are the correct answers. Question number 5. This diagram represents the mixed number 1 out of 1/3. Here we have a whole amount and then a part. Look at these diagrams, write each as a mixed number. Now, we have two full shaded shapes with one part. Can you guess what is the mixed number? We have two full shapes and one shade out of 3, so 1 out of 3. Okay, here we have one full shaded with 2 parts shaded out of 3 parts. So here we have 1 full and 2 shaded parts out of 3 in total. 2 shaded parts out of 3 in total. Here we have, instead of 3 squares, we have 4 squares. 2 full shaded squares with a square that is only one part shaded. So here we have 2 full shaded squares with one shaded square out of 4. Okay, question number 6 in page 87. Which mixed numbers go in the boxes marked A, B, and C? We have a number line and we have boxes that are and we have these boxes. We need to find the mixed numbers of these boxes right here. We need to find out our denominator. Our denominator is how many spaces we have between the numbers. We have 1, 2, 3, 4. So our denominator is 4. We have one whole number, 4a. Our denominator is 4. And the numerator is 1 because it is one part out of 4 parts. So it should be like this, 1 and 1/4. For 2, our whole number is 2. Again, our denominator is 4 because we have 4 spaces here, 1, 2, 3, 4. But here the arrow is on the third part of the fourth part. So we have 3/4, 2 and 3/4. This is our mixed number. For the 3, again, we have 3 as a whole number, 4 as a denominator, 1, 2, 3, 4. On the second part out of 4 spaces, so we need to write it like this, 2 out of 4 parts. So 3 whole numbers and 2 out of 4 parts. We are skipping question number 7 because it's not that important. In our last activity, we should order these fractions or these numbers from the smallest number into the biggest number. It will be easier if we turn them all into decimals in order to ordering them will be easier if we turn all the fractions into decimals. Let's watch how we should turn them into decimals. Again, we turn all the numbers into decimals. One out of 2. Just leave the 1 and only work on the 1 out of 2 because that's the fractions we have. Okay, 1 out of 2 means 0.5. Now, because we already have a full number here, we just move in 5 after the decimal point. That way we have 1.5. Let's look how do we turn 3 and 1/4 into a decimal point. Again, we are leaving 3 because it's a whole number before the decimal point and only work on 1 out of 4. One out of 4 equals to 0.25. But since we have a whole number before the decimal point, our first part is we are only writing down the 25 after the decimal point. First, we are ordering based on the whole numbers. Our smallest amount of the whole number is 1. So we put 1 right here and it equals to 1.5. After that, 2. And then we are left with the 3's. Now we know 3 and 1/4 is equal to 3.25 and is the smallest amount of number because 2 is smaller than 6 and 2 is smaller than 4. So we are putting this first. And then we have 3.4 and 3.6. Alright guys, this is the end of our lesson. I hope you enjoyed the lesson and learned the material well. Please, if you have any questions, leave it in the comments and I will answer you all. See you next time and take care.